So hello everyone, thank you very much for being here and for accepting the invitation to be part of the workshop focusing on AI and medical robotics. My name is Anca Rusu and I'm coordinating the Innovation Booster Robotics. I will tell you a little bit about it in a couple of minutes. First, I would like to start by thanking your router who invited us to this conference to be part of the conference, as well as the organization team of the conference, group members, and my colleagues from Day One Innovation Booster Digital Hub. Today, we are going to start with the panel discussions. We have 5 experts that will present challenges in using your AI and medical robotics. Afterwards, we're going to have a coffee break. And after the coffee break, I'm suggesting to split in 5 or 6 breakout groups, where we can discuss more into detail some of the challenges that will be presented at the beginning in the panel discussion. Afterwards, I suggest we come back in the room and we try to focus on what we found the most interesting as a challenge, solutions, and maybe we can also focus on putting teams together and to try to find teams to solve work that we can think, or stakeholders that we can think can solve any of the problems or can contribute to solve the problems that have been determined at the beginning. And afterwards, definitely, there is a barbecue for those that still can stay here. There is a barbecue on the terrace. So, just to start, the Innovation Booster Robotics startup is financed by Innosis. It's a program from Innosis that is trying to boost innovation, radical innovation in various fields. They're financing, like in food and photonics. Ours is focused on robotics. One of the two main activities of the Innovation Booster Robotics is the financing of innovative, radical innovation projects. They are coming from different fields and different fields under the umbrella of robotics. I will tell you a little bit more about it in a couple of slides. I just wanted to say that when I'm referring to Innovation Booster Robotics, we are a team. We have the management team, also the lead is Professor Odbjer, and my colleague Patrick Mark, who's leading the robotics engagement at HBFL. And we have an innovation committee and the innovation management committee and the steering committee. And they are experts from different fields with different expertise that are also part of the different areas in Switzerland. And they are supporting us and advising us. I said that the booster, on one side, we are financing a project, but also part of our activities is to organize workshops like the one we have today. The workshops are there to try to define problems in various areas of robotics. And we had, like, for example, those are the workshops for this year. We had a workshop focusing on Industry 4.0, on drones, logistics, also on conference accessibility. And we organize a Swiss Robotics Day. I will give you more details about this day a little bit further. But so I said at the beginning we are financing projects. By financing projects, we are financing various topics in robotics. And what it is important is the teams to be part of the teams. There is a need to have a research partner and an implementation partner. It's important to have an academic partner, and after for the implementation partner can be different types of companies like industry, startups, NGOs. But it is important that it's a competition. We have multiple requests. We are financing 10 projects per year in 2 calls, 5 in the first call in April and 5 in September. And the way that we are financing and choosing the winners are on various criteria. We have a reviewing process, a broad review process, but we focus on 5 criteria. We look into innovation aspects of the technology to be radical innovation, relevance and novelty of the team, project feasibility, importance on the economic impact at the Swiss level, and also next steps. It is important for us to see what's the next steps, how the teams, they see the project further. I did not mention that the funding is 25,000 francs for 6 months. So from here, the importance of having visualizing the next steps, what it will be next.
One question. You write here as an example, academia plus industry or academia plus startup plus industry. Is it not possible, academia plus startup only?
Yes, it is. They were just examples.
No, okay.
What it is important is to have academia afterwards and minimum 2 partners. Thank you for the question. So, this is the call in April. We funded 4 projects, not because we did not have enough requests, but this is how the score that they received, only 4 projects can be funded. So I just put it's not. It was the purpose of this slide is just to show that there are different projects we are financing. Because we finance surgical robotics, we also finance drone, floor nourishing, and all the time we have a minimum 2 partners. Minimum of 2 partners. So the next call for proposal is on 15th of September. The application process is straightforward. It's a 4 pages document to be filled in. And if somebody wants to apply, if not, the next one it will be in April 26th and after September 30 next year. And before let my colleague Anna to talk to you also about the Innovation Booster Digital Health Nation, I want to talk to you about the Swiss Robotics Day, which this year will be where the Swiss Robotics Day is organized for 15 years now. This year started to be organized by Innovation Booster Robotics. It will be on 3rd of November in Zurich. Please imagine we are expecting about 500 participants, 50 booths. We organize, there are more details on the website, but the morning will be with keynote speakers, and we're going to have also highlights for the project, highlights from startups, a panel discussion between academia and industry. And the second part of the day, we're going to have booths, 50 booths, as well as workshops, training, job fair. For more information can be found on the website. Now I just let my colleague Jana to present the innovation strategy.
Thank you, Anca. I will just try to speak a bit louder and not steal the mic for a while, because we are here not to learn a lot about the boosters, but more for the panel. I do understand that. As Anca mentioned, I'm managing the Digital Health Nation Innovation Booster, also powered by InnoSwiss. And we are focusing on digital health because it's being executed by Day One for the Basel area. That's why we are also partnering this for this amazing event, as it's local for us and very interesting to participate at. And the Digital Health Nation Innovation Booster also supporting the early stage ideas and moving from the idea to MVP. We yearly select 20 projects to support, but the first batch of 20 startups gets just the initial small funding to test the feasibility in the amount of 3,500 Swiss francs, and then 10 startups get the further support of around 20,000 Swiss francs to continue working on their idea. And besides bringing their own partners on board or creating new ideas from the events that we are organizing, we also have a broad consortium consisting of 16 diverse players and stakeholders that are steering the direction of where the booster goes, helps us to identify the challenges, and also are there to advise their teams to sometimes also partner with them if the idea is interesting, and so on and so forth. And as you can see, the representatives are from different sectors, hospital industry, also service providers, and even insurances. And this year we're focusing on 4 main areas of digital health, because it's also a very broad domain. So we do address the healthcare information quality and access and interoperability, the adoption of the digital tools by healthcare professionals, as well as approaches related to value-based healthcare. Here we are very closely working with the Hospital.2, one of our consortium partners. And of course, patient engagement is empowerment is one of our satellites for all the initiatives that we do day one, not only the digital population booster. And this year, unfortunately, for those of you who are not part of it yet, we already closed the call for applications. So currently, we're working closely with a cohort of 20 projects. But next year, again, somewhere around April, we are going to be onboarding the new teams to support. And therefore, just invite you to scan the code, follow us on LinkedIn, stay connected, and if digital health is something that you are interested in and you already have some idea to discuss, just to reach out to me here during the event or later on, and I'm happy kick off the dialogue. So thank you for your attention.
Thank you. So, and now, the panel discussion. So, I'm inviting 5 experts to return to a pressing challenge in using the artificial intelligence in medical robotics that requires immediate attention and is currently feasible to address and implement. And the 5 speakers are, we have Dr. Diego Paez, who's head of spinal cord injury and artificial intelligence at ATA Zurich, Professor Stefan Weber, Professor for Image-Guided Therapies at Artrox Center, Silvia Runner, Team Lead MedTech Lab, and Liliana Patricia Paredes Calderon, Scientific Coordinator in the Department of Health Science and Technology at ATA Zurich, and Nicolas Gehrig is Deputy Head of Bioinspired Robotics for Medicine Lab, Neuromed Lab. So, please join me on the stage.
Yeah, exactly. But I can just use the hand to share.
We're not going to see the same. No, you have each other education. But you can stay here. And there was some microphone there.
So, yeah. Hello. Nice to meet you. Should I begin? Okay, perfect. So I'm actually in the lab, the biomedical science lab at DHEST. So there are a lot of different labs in the same department, just to make that clarification. And I joined the group 1st of August. Good. Before, I was head of robotics and sports and CTO of FAMED. Switzerland. There's a chain of rehabilitation clinics in Switzerland with neurological rehabilitation, cardiovascular rehabilitation, geriatric rehabilitation, musculoskeletal rehabilitation, and others. So I'm an engineer, biomedical engineer, a bit weird because I'm also a robotic therapist, or I've given therapy with rehabilitation technologies, treating mainly neurological patients, mostly stroke. So I led this project, building this beautiful center that you see here, where we integrate exoskeletons like the exobionics, locomats, some soft exosuits, and then we move towards more devices to train balance and strength training, endurance like Semial or other MTT or medical training therapy devices. So we grew a lot. We motivated a lot of therapists to move into the field of robotics, to use technologies, because we can treat patients more efficiently, a lot more intense with these technologies. And the same counts for our robotics for the upper extremities. So the goal here is to combine conventional therapy with robotics to improve outcomes in neurological patients, of course, for those who is indicated. For example, stroke patients want to walk again. So if we boost the amount of steps that they do, especially in the subacute phase, the chance that they become independent walkers again by combining conventional therapy and robotics is higher, 3 times higher than just giving a physiotherapy alone. So this is shown in the Cochrane reviews. There is the evidence out there, and what we did was to set up the room to follow this scientific evidence as close as possible, but of course taking on account the importance of the clinical day life, which is, you have to treat as much patients as possible from 8 to 5 in the afternoon. So we designed these process chains of treating patients depending on their functional ability. For example, for the lower extremity, if the patient cannot walk, Then we will start treating them with Erigo to reach cardiovascular stability, and then very soon with the Locomats and the Exos to boost the walking ability, so to do many steps per session. And if the patients got better, could walk maybe with one person or with walkers or with a cane, then we boost their walking ability with treadmill, with semi-mill, with Andago, and we started exploring robotics for home use. So I have a short video. I don't know if maybe you have to click it or I just, yeah, you work with this, right? Or no? No, it stopped. But I want to show, I think you are familiar with these kind of machines. Why did I bring it here? Because I will address some challenges and opportunities in a moment. The machines do a whole lot of work already, and they are very useful in the clinical setting. Yet we as therapists have to be there all the time to adjust the settings of the device, to modify the challenge of the task so that it is actually useful for the patient, that as he improves, we challenge him more and more. So here I come to that. What are the opportunities? So all these devices have already a certain degree of AI, basic AI, if we think of that, like automation and guidance, but not advanced AI. So they are not adapting yet, most of them, to the abilities of the patients if they improve. So we as therapists have to be quite attentive to adjust these devices all the time. Another point is the devices don't talk to each other and they don't talk to the EHR. So we are not bringing all this data together to learn if this patient with this prognosis is training this amount of minutes, and with this type of therapy, are the outcomes improving or not? And I believe this can guide clinical decision making to a large degree. It's a challenge to come inpatient. So maybe there are possibilities to start with this integration of technologies and medical data in the telehealth and telerehab. And this is actually one of my personal innovation projects where I look for systems like this in the telehealth field to have more device connectivity, comprehensive therapy plans, even integrating devices and wearables, and where we can integrate AI to make predictions of improvement. And then maybe there is a possibility to come in the inpatient setting where there are big players in the market and it's not so easy to integrate everything. Maybe the link, we are boosted by the Day One Innovation Booster, which Jana mentioned before. Challenges. So, inpatient, definitely the new tariff system for inpatient, where it says every patient has to get 540 minutes per week on average during the stay. So we cannot decide based on this prognosis this patient gets better or not. We have to divide the resources equally among these patients. So we know AI and the state of art. There are systems that can make these predictions, but we have some regulations, laws where we have to divide the resources. So I hope that when this data integration happens, and we make it happen, that these tariffs are also adjusted. And for the home setting, definitely reimbursement is a big issue. So I'll mention the most important things. So here is the compulsory insurance space for treatment, not for devices that are being developed. It takes time, 2 to 3 years to get approval by Swissmedic to get this scientifically go. validation, and also by the Federal Office of Public Health. We have to show if we develop a treatment that should be paid by the complementary insurance, and it has to be cost efficient, economical, effective, appropriate, and suitable. And if we go for something that is more on the field of prevention, so it will be more on the paid for the complementary insurance. Basically, we have de facto the same criteria, but the decision to pay for it depends on the insurer. So there are many rules according to the insurance chosen. And with this, I finish my presentation, and I'm happy to discuss any of the topics with you in the afternoon.
Thank you very much. Diego.
So, good afternoon. Sorry, I was not integrated with the system here. So, my name is Diego Paz. I run a lab between ETH and the Swiss Paraplegic Center in Knoxville. And I think my talk is very close to what Juliana was just describing, all the problems that we have with inpatient rehabilitation and how it relates to the medical technology that we are developing. But I want to take it just a bit further than that, to the point of outpatient life. I want you to think about what is the life for chronic disease, where you stay with the disease for the rest of your life. So rehabilitation process is not just what happens within the hospital, but it's what happens for the rest of your life, for you to get used to functioning in your normal life. And to bring you to that point, I just want to bring it a bit closer to you. And it is clear that we are all getting older, but not just as a person, but as a society. And by 2050, we are going to be a super aged population, especially developed nations, as ours. We don't live in Switzerland. So this means that there's a shift in the medical field between the burden that is being in specific conditions, and this is being shifted, especially for the elderly population. You get now the burden to what is called non-communicative disease, so chronic conditions, cardiovascular disease, diabetes. This thing that tends to get further when you get older. And this becomes chronic phase conditions and long-term recovery. So we need a lot of support into what it becomes your normal life. This is going to be part of the medical field. And now, if I just give a specific example, this is the Japanese population in 2045. The highest peak is at 75. So we are shifting the entire population. And we don't have nurses, doctors in the bottom of that to support that population. And something very interesting is that the health of a 75 person in Japan is exactly the same of a Swiss person. It's actually 76.1. So in our developed societies, we are seeing this trend that we're getting very healthy into very long age, but a lot of population is shifted in that direction. After that point, it goes down. So we have to understand that chronic conditions are going to be permanent for most of the population and for most of us. So when you go to rehabilitation, this comes out of the Rehabilitation Engineering Center in ETH, and where we want to have a holistic approach that you see the entire process. Right now we have been talking about inpatient rehabilitation, what happens in the acute phase, what happens in the subacute phase, when you have therapy, then you have chronic rehabilitation. Then this is the first 3 phases, 3 to 12 months, when you are very lucky, like in the spinal cord injury, in the Swiss Paraplegic Center, persons live there 6 to 12 months, and they have an excellent treatment. Then they go into outpatient life. And then you have still rehabilitation, reintegration, secondary health condition prevention. And these last for the rest of your life. there is still, in my view, a lot of attention that is needed at this point. Because secondary health conditions are a big burden, again, for the health system. Now, I'll bring you a bit to a specific example, and it's what we work in our group, and is spinal cord injury. I would assume most people understand what is a spinal cord injury. To some extent, you know that it's an injury that occurs to your back, the bone. So in the spinal cord, when you have a disruption, it affects your nerve, then you stop your sensory motor system. The interesting thing is that it could happen to anyone. So, and it happens yearly to over 500,000 people worldwide. And it goes to this process of inpatient rehabilitation. And we are getting very good at it, and it has been improving a lot. So there are magnificent tools that we have developed, and at each hospital they have been implemented and developed. As Juliana mentioned, these tools are isolated, so we don't get this information, so we don't know how was the life of the person during the rehabilitation for the rest of their medical records. We get the snapshots that the physiotherapists take out of them. So this is one big problem that I have also noticed with our group, our hospital, the other clinics that we work with, they all notice this problem. They all have to do manual work into writing down what the person did at that machine. This is a bit, a bit outdated for us engineers that know that everything can be automated. But this is my first point. Now, when we see the person now here, what do you see there? So I don't want to make it too long. Everyone else see maybe something different, but what we see is the difference in the way they will experience the rest of their life. They are sitting, we are standing. So one of the first approaches I took in my early career, and I learned from many people, was assistive robotics. Assistive robotics try to help these problems, and we try to focus on solving one of them. It's social, and it's also a medical problem. Standing. Basic thing. How can we make a person in a spinal cord injury to stand and live their life standing? Of course, you can take an automated robot with 7 degrees of freedom and lift them up, but you cannot make this a product. So we designed a system that is fully passive and take the standing wheelchair, the person can drive around, and it doesn't have any actuator to lift it, so the person can sit and stand by their will by shifting their weight, which is actually something very simple to do. And we try to make it a product, and disclaimer, I'm part of the company. This is our product in Japan, not here yet. But we try to build the system to be a wheelchair for the person to shift this perspective, that they live their normal life close to the normal functioning of us, healthy persons. So, and that's a basic function, standing. Now, when we go a bit more in detail into what is a spinal cord injury, what you see here, I'm not ask you specifically, but you see all the systems that are inside each of us. And a spinal cord injury would affect each and every one of them. So instead of cardiovascular function, it becomes cardiovascular disease, pulmonary infections, urinary tract infections, pressure injuries, sexual dysfunction. All of these functions turn to change, and it's individual. Each person is unique because the level of the injury affects your own distribution of your nervous system, affects how it behaves. What I want to say is there are many problems, and these are chronic conditions. So we have to follow them for the rest of the life. And this is part of the medical support that we want to give. So one of the ideas that we work on is in how to close the loop, how to go from, we have the person in the hospital lying in the bed, we get some information, we transmit it, we share it, the doctors make an assessment, make a therapy, they go in the patient, but then when they go to their wheelchair and they go to live their normal life, we don't want to break this loop. There's a lot of information that will help to prevent the secondary health conditions. And we want to extract this information to help the person live a normal life. We are working with different partners. One of them in Japan is the National Center for Geriatrics and Gerontology. They also see the same problem for elderly population because they are left alone. Many of them, 50%, live still in a wheelchair also. So we have very similar problems that come together. There we are trying to go not from inpatient, go from inpatient to outpatient. Not just monitoring during the stay, but we are simulating in an environment how is the normal life, and what information can we get for improving their daily life. So this comes to conclude what I wanted to show today. And within the whole loop, what I see still as a need is how to share the information, how to monitor the person. And here we have data science. We have AI to build models around the person. But this is possible and it's always done in isolated environments. Each robotic device, each assisted device, each unique clinical study yields one result, and the data is never shared. We don't have information that allows us to build larger models and larger understanding of what happens to the person. This is what we need for the outpatient life. This is what we need for the rehabilitation, for remote rehabilitation, and in general for long-term care. Thank you very much.
Penguins, yeah.
That one is good.
Yeah, and the challenge.
Very good. Okay.
Thanks a lot. Okay, actually, I'm also gonna go in a very similar direction as Liliana and Diego, because I'm also coming from rehabilitation robotics. Also currently mainly working with spinal cord injury patients or users, as I would call them. And currently I'm working with the Eastern Switzerland University of Applied Sciences. There we have a small group where we develop robots mainly for personal mobility, speak wheelchairs and exoskeletons, and the merger of the two different approaches. I'm not going to dive too deep into what I'm doing in my everyday job, but for today I'm going to very strongly advocate for human-in-the-loop systems when it comes to medical robots and artificial intelligence, because as probably all of us know that if we over-automate, that leads to a huge lot of risks and to very unhappy customers in the end. We did a lot of user research. Our main focus in any project is that we really try to do user-centric design, user-centric development with all the stakeholder groups involved in the very early stages of any development. And one thing we learned from basically any interview is that the users want control over their mobility devices. They want to be in charge of what happens and they want to be able to decide at any moment. So what has never worked so far is that if you put a human in a mobility device, it just transports as if you're using public transport or something. That is not going to make your users happy. Also from the other perspective, I identified 3 factors which really force this collaboration between the technology and the user, one of them being the safety. So if you have a system with a lot of technology and a user inside, you can reduce the risks massively by correcting each other's errors. So if the technology makes a wrong prediction, for example, if it's an AI, then the user can react. And if the user makes a mistake, as all of us humans do, then maybe the technology can react. So the safety is the level of safety is much higher if you have a human-in-the-loop system. Another aspect is definitely the regulations. I'm not sure how many of you have brought medical devices to the market. It's a nightmare, basically, with all the regulations we have to follow. And currently, also, the system is not made for any type of AI-based medical devices. So it's very hard to, as we all wish, the device learns about the patient and then adapts itself. That's a huge challenge. to bring to the market. It's also a technology challenge, but it's also a regulatory challenge. Currently, the outcome of any medical device software has to be deterministic, so it's not allowed that it learns and adapts itself. So that's one of the aspects where I see that you need human-in-the-loop systems as well. And the third one is definitely the user experience, because if you have a bad user experience for a user, the user's just not going to use the device. It's going to stand somewhere in the corner, either in the clinic or at home, depending on the device, but it's not going to be used. So my first area of challenge is basically environment recognition for the mobility aids. We started exploring this field a little bit with some cameras first, and then some depth images where we tried to detect stairs and steps. Try to find a system which proposes, hey, I think there's a step ahead and your trajectory should look as follows, because it detects the height and the depth of the step. We did have some decent results. It's probably okay, nothing which is ready for a medical device yet, but as I said, we're a university, so it's a start. But if you imagine again sitting in a wheelchair or standing in a wheelchair or whatever, walking in an exoskeleton, then your cognitive load is much higher because you need to find out how to navigate all the obstacles which are in your environment. And you also typically have to consciously switch a mode in your medical device you're using. And my challenge for you today would be, how can we reduce this cognitive load to the level of the cognitive load of pedestrians? Also, second one is, if you have an AI in the system and a human which does the final decision of what is going on now with my device, how would a user-friendly user interface look like? How can we make these systems really usable? So that's probably also for the breakout session going to be the topic which I would love to discuss with some of you. A second one, which I also, from my background, which is very close to me, is documentation. As you might have learned, I'm a little bit traumatized by bringing medical devices to the market. Documentation is a huge topic, and there's a huge set of documents which also increases the level of safety and which makes your product compliant with all the regulations. You have typically some database structure where you put in requirements, risk management information, also usability, standard testing, a huge lot of information. All of that information has to be aligned throughout the whole life cycle of your medical device. And it's typically maintained manually. I see huge potential for AI there, and it's also there in the end. If a human is somewhere in that system, and the system proposes, hey, I think if you have from your post-market surveillance that there's a new risk coming up, then it could also propose, hey, maybe in the user instruction we need to adapt at this point, and then in the end a human should decide what is really happening there. So that's a second level of challenge. I think we won't discuss that specifically today, but I'm also happy to discuss that type of stuff in the break, or whenever. Just get in touch with me. I would love to bring that field forward as well. So, quick summary. Today, I would like to foster a partnership between the users and the AI and increase the safety, regulatory compliance, and also the user-centric experience.
Now we're going to have a short talk from Nicola.
So, welcome everyone. I'm happy to welcome you here at the University of Basel. My name is Nicola Gerig. I do not have so many slides prepared, so just orally my background is also in sports training simulators and rehabilitation engineering. I did my PhD at ETH Zurich and Baldur's University Hospital, so it's a very close connection despite I left before you joined. So in my past, I was working on a rowing simulator, so it's a large human-machine robot with very dynamic movements and very strong motors that could break a human spine. I then moved over trying to transfer these learning concepts and assistive strategies that we had to a arming robot, which was commercialized as Omeo powered by Okoma. I worked a bit in the field of automated training success evaluation and then predictive models that help the therapists to choose other training support. And then finally moved here to University of Basel, where I'm working more in a surgical feasibility research, I would say. So most of the projects that we do at the Pyramid Lab are in an early stage, where we are looking at technical feasibility. So how can we make systems that support, what can we do, what accuracies can we achieve, can we make minimal invasive laser osteotomy happen. So my job here is, again, mostly the projects of human-machine interfaces. We have presented by my PhD student Moralikana admittance controller using a commercial device, a KUKA LVR IVA with our own custom handle to do hand guidance in 60 degrees of freedom. The challenges, if you look at my bio, is I moved from very strong, very dangerous robots with a high dynamic to quasi-static movements with high precision, so it seems everything became easier, but it did not. The problems are very similar. And the major problem, I think, is, besides regulatory things and issues that I personally have when suddenly patient data becomes part of an algorithm, how this is being handled here is just complexity. Complexity and openness of companies. We do not want to redevelop the wheel. If we are in the surgical field, we have requirements, we figure out what is needed, and then we do not want to build all the robots from scratch. So we want to use what is on the market, and the big problem we have there is learning curves of manufacturer-specific knowledge. And do we use those devices according to their intended purpose, or do we lose all the certification? And so this is one of the biggest challenges I face supervising my PhD students. They have to provide scientific output, so they have to develop a system. They have 3 or 4 years of maybe no output, and they're still expected the same amount of scientific outputs as non-engineering students. We don't have any funding for technicians. We don't have funding for technical workers that also keep knowledge in the academic labs. This is a big challenge. I am very happy that we have events like Anca Innovation Booster, and I'm very happy that at the Pyramid Lab, I, together with Morali, just received an NTN Innovation Booster to continue working on this project where we do endoscope hand guidance steering with a Stoiber robot, and I'm really hoping that they are a bit more open on the interfaces we can use. And the second part is we also got a float from Vehastim. I don't know if you know that company. It's a company that Georg helped to put the product on the market, and the technology is based on the rowing simulator that both he and I did our PhD on. So the very unique situation we get there is that we will be able to hot swap the control cabinet from a CE-certified medical device for therapy to our own research code base where we can do whatever we want. So I hope that in the future the companies also see the gain in these kind of situations, and that with those kind of collaborations we can reduce the complexity and the problems we currently face. I'm open for any questions, and to achieve the state where we get the certain requirements, most of the time we have to have a working demo. So there's a lot of developmental work until the key stakeholder can finally tell us or figure out what he actually needs. So keep that in mind. With that, I would like to thank you for your attention and hand over to the next fellow speaker, Stefan.
wait for a second until the machine is coming up. I'm glad I'm in here and not outside today. That's very warm. Good. Here we go. Perfect. Good. My name is Stefan Weber. I'm German originally. I work in Bern. I used to be a professor for image-guided therapies, and since 4.5 years I lead this company called Fascination that I founded 14 years ago. I'll give a bit more of an industrial perspective today, hence a bit more of a critical perspective also. Before I do this, let me share with you some technologies, products that we sell, develop, market, and support in clinics around the world that incorporate either AI or robotics. This is a technology for interventional oncology to guide and assist interventional oncologists in placing minimally invasive ablations to treat cancers in lung, liver, kidney, pancreas, bone, and musculoskeletal tissue. The technology as such, described by regulatory terms as a decision support system with navigation functionality, comprises a piece of software that displays DICOM data in 2D, 3D, supports some navigation of needles into the human body, and it also incorporates a significant portion of deep learning-based so-called AI segmentation functions for identification of liver, lung, kidney, portal vein, hepatic vein, airways, lung blood vessels, and bones and skin, of course. They can also measure the outlines of tumors, margins, ablation volumes, and so on. The technology is cleared in Europe, in the United States, and in China. We have built this in. There are a couple of thousand patients have been treated, and we're moving forward every day with this. And there are some statements that I will have about AI in this field. Another product that we do is robotics in cochlear implantation. I put this blurred picture up because I didn't have access to my files here as I was traveling. This is a robotic device that assists in cochlear implantation. You all might be familiar with cochlear implants. Implants that are implanted to help or to bring back hearing to otherwise deaf patients. There's a lot of discussion about how you get those implants in, from which angle, which speed, in order to come forward with ultimately much better hearing outcomes. Today there are 80,000 procedures, cochlear implants per year, and there's an understanding in the community that approximately 50% of recipients of cochlear implants do not have implant performance as they could have. And one understanding is that the implantation procedure itself kind of created problems. Yeah? So to make this implantation reproducible from outcomes, move the baseline of the average quality. This is what we do here. And the machine, as you can imagine, the cochlea has a structure somewhere here, 25 millimeters inside. Cochlea is 9 millimeters in diameter, has a little hole called the round window. The round window is 1 millimeter in diameter, and we need to create a drill hole from the outside of the skull to the cochlea. And in order to achieve this with the robot, this must be a robot that automatically, some call it autonomously, drill holes towards the cochlea. The moment someone touches that robot, it will deflect by a couple of tens of millimeters, and this is, I go probably to jail if something happens. So the machine is somewhat automatic, autonomous, and conducts this procedure on its own. And there's one more technology that we call Autoplan that we have available around the world, which is a decision support system for planning of otological procedures with a focus on cochlear implants. It also integrates a couple of AI-based segmentation functionality that's available in Europe, in the United States, and in a couple of other countries, Brazil and so on. So I would say we know what we do. We develop these technologies. We can clear them regulatory-wise, bring them to the market, and we operate them on the market in conjunction with marketing, sales, and so on. And on a bit more, I would say, controversial statement here, I would say there's a lot of hype around AI and robotics. It's not clear who benefits from this hype. Is it investors? But I'm fearing that at some point the hype will come back and kill a lot of stories. Companies, young startup companies that potentially die because they cannot deliver around the hype. There are significant claims being made, both by academia and by industry. Early industrial ventures, I would say, that claim things that to the experts, of which you are a lot, would easily say, it's very critical if the technology can ever achieve this. And I'm afraid that this also comes back. There is, to my taste, there's little to no discussion about economics. Who pays for this? Hospitals, and this is where I get my gray hair from. Hospitals do not buy technology because you claim they are AI or robotics. They want to hear what is the cost of the technology and how much does it bring in terms of increased revenues or decreased internal costs. That's it. Yeah? And if you can't sort it out on an Excel sheet more or less, you can leave the room after 1 hour and call it a dead sales. Yeah? And the last thing, which is in a different direction, but it's actually quite crazy, overregulation. Europe is about to bring to the light of the day the AI regulation. Yeah? And I don't know who has read this regulation draft. If you check out the definition of what is AI, it's of course deep learning, but it's also statistical shape models. And there was a draft, I don't know if it's still in there, in which they said simple regression models are also AI. Fair enough, yeah. But then if you go further to paragraph 120, whatever, you will read that AI technologies that are incorporated in technologies that are otherwise regulated by notified bodies, medical devices, automatically those devices become high-risk AI things. Yeah? So now tell me if I have a little segmentation thingy here that segments a tumor or whatever, suddenly becomes a high-risk AI, and on top of my hundreds of thousands of dollars that I pay to the TÜV every year for them to read papers that I produce as part of the medical device approval, I now take the same piece of documents and submit them to another notified body, which is called TÜV AI, whatever, yeah? And I easily double my regulation costs. Yeah? We need to hire AI experts that are basically creating a huge bureaucracy in Europe. Yeah? And before all of this can start, the regulation will kill it all. Yeah? And maybe I'm overly critical. Maybe that's good or bad. I don't know. But thank you very much for the attention.